So solving for x, and we're doing more skills. So we talked about last time, if I say 3x plus 2 is equal to 8, we talked about multi-steps, how we could solve for x, taking into account that there's more than one item there. So what we did was, we went ahead and we said, we want to identify the variable, followed by what numbers do we want to get rid of. Now, when you first start off, you might say, oh, I don't want to label this, but it's helpful to get your brain used to this process. And the process is for me to say, first, what am I trying to do, my goal? So I'm trying to get x equals 2. Second, x is not alone. There's a lot of people around it. So that's slowly get rid of them by doing opposite operations. So to get rid of it, we want to get rid of the 3 or the 2 first. And the question for you guys was, which one was farthest away? So let me pause here. So quickly to review, the way we solved this problem is we subtracted 2 from both sides because we're trying to solve for x by itself because we want x to be lonely. That became a 6. Then we get rid of the 3. Opposite of multiply by 3 is divide by 3. And we're left with x is 2. We can double check it. 3 times 2 plus 2 is equal to 8. That becomes 6 plus 2 is 8. Yes, this is a true statement. We found the right x. Okay, so to continue this idea, what if there's more than one x floating around? What if it's 5x minus 3x plus 4 equals to 10? So more x's, more trash. Maybe I shouldn't say more trash. Maybe more, just say more stuff. Let's go, why'd you have to say trash? Why'd you have to go that way? More stuff. Now, we still consider, we have to think about the question, what am I solving for? I'm still solving for x. And we still have to get rid of some numbers here. But let's first deal with our first problem. X is in too many spots. Let's see if we can combine them together. And one of the ideas that we work with in Algebra 1 is combining like terms. And like terms is the idea of things that are in the same type of group. What I mean by group is that x's are with x and numbers are with numbers. We have 5 somethings minus 3 somethings. And turns out those are both the same quote unquote somethings. Sometimes people teach it this way. I have 5 oranges and 3 oranges. Well, 5 oranges minus 3 oranges, that leads us to become 2 oranges. So I can combine these together, 5 minus 3, because they are like terms. But is 2 and 4 like terms? 2 oranges and 4 what? You're not an orange. Well, you're an avocado. So these are not like terms. So we describe these as not like terms. So you can always combine like terms together using addition or subtraction. And in this case, it was a positive 5 minus a 3. So that gives us a positive 2. If you have $5 and you spent $3, you have $2 left. This is equal to 10. Okay, now we're back to our basic problem. And the cool thing about algebra, it always takes us back to something that we know, something easy that we've done before, a skill that we previously mastered. We go from something ugly back to a previously understood skill. So this question here, do I get rid of the 4 or the 2 now? Give me 1 second. Let's set up a, no, I'm not gonna set up. It takes too long. Okay, so would I get rid of the 2 or the 4? Let's get rid of the 4 because it's farthest away. Minus 4 with both sides. Thank you. 2x is equal to 6. Almost done. Divide by 2. Why am I dividing by 2? What is 2 doing to the x? 2 times x, so opposite of multiply, is divide. X is 3. Now, would this have worked? If I plug this back into my original problem, 5 times 3 minus 3 times 3 plus 4 is equal to 10. Well, didn't we say 5x and 3x were the same type? And now you can see that it's 5 3s and 3 3s. 5 3s and 3 3s. And we can combine those together. 5 3s and 3 3s. Let's go finish up the math. 5 times 3 is 15, minus 9 plus 4 is equal to 10. If I combine these together, 15 minus 9, 5, 1 is 6. 6 plus 4 is 10, and that is a true statement. Okay. Now, that's great. We found the value that works. Now, does this always work? Well, let me rewrite this a little differently. What if I wrote 5x plus 4 minus 3x equals to 10? What if I mix it around? So look at them. They look similar, but they're in a different order. And there is a math skill called associative property as well as commutative property. Now, commutative property means it doesn't matter the order. So with addition and subtraction, you can rewrite this. I can rewrite this by shuffling it around and say, excuse me, 5x minus 3x plus 4. And that is okay. We're just shuffling it around. Now let me ask you a question. With addition, is 5 plus 4 plus 3 the same as 5 plus 3 plus 4? Is this the same as 3 plus 5 plus 4? And the commutative property is called commutative. Commutative, it's like we're in a community, so it doesn't matter who goes first. You can go first, old lady. You can go first, young man. The order doesn't matter. And that works for plus and minus. But for minuses, you have to make sure you carry the negative with you. This is not the commutative property if you mess up. For 5 minus 3 plus 4 is not the same as 5 minus 4 plus 3, right? In one problem, I am minusing 3. Another, I'm minusing 4. That is not the same. But what is the same, what does work, let's write this over here, is 5 plus 4 minus 3. That does work because the negative still went with a 3. That's still a minus 3. So let's do one more quick problem here. If I say 4x plus 6 minus 2x equals to, let's do 8. Now, if you look for this problem, I do have x, and these are like terms. These are like terms, but they're not next to each other. But it's okay because the commutative property says I can shuffle things around. I can shuffle pluses and minuses around as I want to. So we can rewrite this. Excuse me, sir. Excuse me, sir. Excuse me, sir. So it's going to be 4x minus 2x plus 6 is equal to 8. So that instead of having a bunch of x's everywhere, we can combine those x's together. Okay, that's right. 2x plus 6 is equal to 8, minus 6 to both sides. 2x is equal to 2, and then we can divide 2 to both sides. X is equal to 2 divided by 2 is 1. Okay, now hopefully that was kind of okay mentally. So let's go ahead and move on. Our next problem is going to be parentheses. And we're going to work with something called the distributive property. And the idea of the distributive property is that we're going to multiply numbers outside the parentheses. Let's write it. Let's say it's going to be 3 times 2x plus 4 is equal to 18. Okay. So there are two ways to go ahead and try solving this problem. There are two ways. There's more than one. But we're going to stick with what I think is going to be the easiest one for everyone to get started off with. And what we do is we say, what is the 3 doing to this parentheses here? Is it adding, subtracting, multiplying, or dividing? Adding, subtracting, multiplying, or dividing. And since we mentioned before that any number next to a variable means multiplication, the 3 is multiplying the parentheses. So we're going to distribute. Distribute means we're going to multiply everyone by everything. Everyone by everything. Now, let me give you an example of this in real life. You guys ever have something called a Lunchable? You guys ever have a Lunchable? And in this Lunchable, you can get something like pepperonis and cheese and juice boxes. So we get like pepperonis, we get like 3 pepperonis, we get 3 crackers, and we get like 1 juice box, right? Wait, let me choose the letters. I don't know why I did that. We get 3 pepperoni, 3 crackers, and 1 juice box. Okay. What if you bought 3 of these? So don't you get 9 pepperoni then? And then don't you get 9 pieces of cheese? And then don't you get 3 juice boxes? So this is the idea of distributive property. I have 3 parentheses. So that means I really have 6 x's here. I have 6 x's. I have 12 constants in this case. And is 18 on the same side? Is 18 being multiplied by the 3? No, it's already escaped. It's on the other side. So whenever we're multiplying a number by parentheses, we multiply everyone by that number. We have 3 2x's. That means I really have 6 of them. I have 3 4's. That means I really have 12 of them. Go Lunchables. They're not that good anymore. Okay, now look at this. This is back to an easy problem. We want to solve for x, so we get rid of the numbers 6 and 12. So I'm going to go ahead and subtract 12 because it's farthest away. 6x. 6x plus 12. So darn it. 6x is equal to 6. How do I get rid of a times 6? We divide 6 to both sides. X is equal to 1. So I'm going to throw a negative into the mix now and a fraction at the same time. A negative and a fraction for our next example. Okay, let's repeat what we did here first though. I'm multiplying the 3's. 3 times 2, 3 times 4. That gives me a 6 and a 12. Which one is farthest away? The 6 or the 12? The 12 is farthest away, so we do opposite operations. Opposite of plus is minus. 18 minus 12 is 6. Next move, how to get rid of a 6 times x? Opposite of multiply by 6 is divide by 6. And then we're left with 1. Okay, let's kick it up a notch one more time. Negative 1/2. We're going to say solve for x. 1/2. And we're going to say 6x plus 8 is equal to 8. Okay. 1/2 times 6x minus 8 is equal to 8. So we identified the problem that we have to solve for. We're solving for the letter x. We got a bunch of stuff we have to get rid of. Before I can even get started getting rid of this stuff, I want to get rid of the parentheses. We mentioned before in our last problem, how to get rid of the parentheses? We have to multiply this to the front and to the back. So I'm going to write this out and take my time with this just so you guys can see. What is 1/2, negative 1/2, times 6? Well, 6 divided by 2 is 3, and a positive times a negative is a negative 3x. What is 1/2 times 8? Let's write it, negative 1/2 times 8. What is 8 divided by 2? That's going to be 4. Let's be negative 4. Now it goes back to a problem that we had before. Back to this is like a level 1 problem. Now we use our identifying of my variable, and then I have to get rid of the 3 and the 2. No, 3 and the 4. How to get rid of a minus 4? We add 4 to both sides. Negative 3x equals to 12. How do we get rid of a negative 3? Now be careful. Is this negative 3 adding, subtracting, multiplying, or dividing into x? Adding, subtracting, multiplying, or dividing into x? What is it doing? It is multiplying, okay? Remember, if a number is next to a variable, it's multiplying. So the opposite of multiply is divide. We said before, we're going to divide everything, including that negative. Negative 3 divided by negative 3 becomes a nice, easy cancel out to become 1. And 12 divided by 3 is 4. But remember, a positive divided by negative is a negative. Okay. Now, I'm going to spend the next 3 minutes working quickly on this next example. And the next example is with variables on both sides. And again, I posted a link in the homework to the video, so you guys can click that link and it'll take you directly to the YouTube video right at that point. But I want to try to spend some time on it right now. Variables on both sides. If I write 3x plus 2 is equal to, let's do 7x. So the hint here is I'm solving for x, but I see x on both sides. Now I'm going to tell you this. I think it's easiest to, there's actually multiple strategies. But first is, if x is almost alone, move it to the side that's almost alone. That's perfectly fine. So I see x is on the right side and it's almost alone, right? Or it is alone. So it is alone. So if I ask, hey friend, why don't you come over to my side? Then we can chill. Imagine when you're with your, let's say you're at home and you want to invite your friends, but you have parents at your house, but your friend doesn't have parents at their house. Do you say, come over to my house with parents? Or, hey, let me come to your house with no parents? Tough decision, right? So if this is me without parents, without anyone bothering me, I can ask my friends to come over to my side using opposite operations. 3x minus 3x, that cancels out, right? Again, the idea is, hey, there's less stuff going on over here. Why don't we move the x's to that side? 2 is equal to 4x. I still have to solve for x. Let's get rid of the 4. Opposite of multiply by 4 is divide by 4. X is equal to 1 over 2. What if I have a problem that says 3x plus 2 is equal to 7x plus 6? No, not plus 6. Let's do minus 6. So look at this example here. I have x's on both sides. right? I have x on both sides. You have 3 there, and you have 7 there. My hint here, here's a hint. Move to the side with more x's. Which side has more x's? You guys ever go to a friend's house? I mean, we used to do this a lot. I would always go to my friend's house with more toys. I didn't have good toys in my house, but a couple of my friends did have a lot of nice toys. They had like the first Nintendo. I didn't have a Nintendo. I'm coming to your house to play Nintendo. So, do you want them to come to your house with less toys, or do you want them to come to your house with more toys? Come to my house, yo. So, what I'm going to do here is I will always try to combine the x's first to make it easier on me. So I know I need to combine the 3x and the 7x. So let's ask the 3x to come over using opposite operations. And I'm combining those with like terms. The 7x and 3x are like terms. 2 is equal to 7 minus 3 is 4x minus 6. Now we're back to a problem that we solved before. What am I solving for? Letter x. I have to get rid of the 4 and 6 to be alone. Which one is farthest away, the 4 or the 6? The 6, so plus 6 to both sides. 4x is equal to 8. Then we divide by 4 because opposite multiply is divide.